Well, welcome to lesson 24. We march on with our look at decimal numbers. We want to look at operations with decimals today. You have hopefully done this worksheet. You have hopefully done these questions so that it's not crazy when I start adding together a couple of area codes, right? And then adding these numbers and asking ourselves, what is the similarity? Why do we do what we do? Well, in the same way that we lined things up, ones, tens, hundreds, and the whole system is based on place value, the same thing happens here. These are ones, these are tenths, these are hundredths. And just like in this algorithm, we add by place value. Every time we get bigger than 10 here, it carries into the next place because each of these places is 10 times as big as the place to its right. So for the same reasons that this algorithm worked, this algorithm works. This algorithm is based on place value. This algorithm is based on place value. There is no difference at all between why this works and why this works. Subtraction is a similar thing with one important caveat. When we subtracted whole numbers, we always write justified. So we would not have written 2105 minus 523. We would not have written that way because then you got your ones places off and your tens places are off and your hundreds places are off. Everything would have been right justified. Here, we don't write justify, we line up at the decimal point because that keeps our place values set, right? Ones, tens, tenths, hundredths, thousandths, right? Those are the places. Then you start at the rightmost place. You can't take 3 from nothing. Remember, that's nothing. So you borrow. You borrow 1 from the hundredths place, leaving that empty. That 1/100th is 10 thousandths. 10 minus 3 is 7. Then we play the same game. Can't take 7 from 0. We take a tenth away. That 1/10 is 10 hundredths. And 10 minus 7, can't take 5 from 1. We take the 1 away from the ones place. That 1/1 is 10 tenths, and we can subtract like we're used to. So there are two things for us to keep in mind when we look at subtraction. One is that borrowing runs exactly the same way as it ever did. When we borrow, we are stealing from a place and bringing over 10 of the next thing down. The other thing to remember is that you may have to fill in with zeros to be able to subtract. The same sort of thing would happen if we were looking to subtract 2.021 minus 1.35. If we were looking to do that, we would look at the thousandths place and we'd say, well, 1 minus what? Well, that's a 0. 1 minus 0, that's 1, and then we can't borrow. We can't do this subtraction. 2 minus 5 is negative, so we'll bring that over, and there's nothing to borrow from here. So this 1 This one that we're borrowing is 10 tenths. And then we borrow one of those tenths, and that 1/10 that we borrowed is 10 hundredths. And so 12 minus 5 is 7, 9 minus 3 is 6, 1 minus 1 is 0. So the same thing happens if we fall short of decimal places down here. We make sure that there are as many decimal places with the one number as there are with the other number so that we can subtract either this way or that way. It doesn't really matter. So those are two things to keep in mind when you're subtracting. Um, when we multiply, so let's remind everybody how we multiply. 276 times 34, and we're saying, okay, I remember how this goes, right? 20 plus 2 is 30, and then 8 plus 3 is 11, and then 3 times 6 is 18, but that 8 goes here, right? Because there's the placeholder there, and we remember this from before, right? So that's 20, that's 22. Is it? It is. 22, and then 6 and 2 is 8, and so we add, and adding's not hard, right? And so you got 9,384. Gosh, I hope that's right. So what changes when we come to here? What changes? Well, not much, right? Not much. You're taught to do this as if it were that, right? You're taught to do all the same things. Right? You're taught to do it as if the decimal points weren't even there. But then you're taught to do this crazy thing. You're taught to say there are 2 decimal places here and 1 decimal place here, so there have to be 3 decimal places in the answer, and so the answer is 9.384. Did you ever ask yourself why that works? Did you ever ask yourself why they get away with that? What sort of sorcery is involved in just moving decimal points around, and what is that? Well, here's what's really happening, if I may be so bold as to say. This right here, this 2.76 times 3.4. Well, this 2.76 is 276 times 1/100th. And this 3.4, that's 34 times 0.1. So now I'm going to use myself the commutative property. I'm going to take advantage of the commutative property and say that that's this. Well, this part we already figured out. What does this part do? This part multiplies, so let's see, let's stick with it. The 276 by the 34 is 9384. The 0.01 times the 0.1, that's so this is 1/100th, this is 1/10th. Those multiply to 1/1000th. So this final answer comes from doing the multiplication as if there were no decimals and then recognizing that there are. So this has 10 to the power of minus 2, and this has 10 to the power of minus 1. So together that's 10 to the power of minus 3, and that's why you move the decimal point 3 places to the left. That's what's going on behind this process. It's not just, oh, well, we count decimal places and we count decimal places and therefore we count decimal places, because we don't do any of that here. We don't care about that here. We don't care about that here. Why? Because we don't care about factors of 0.01 or factors of 0.1 when we're adding or subtracting. We care about those factors when we're multiplying. And the same thing happens when we divide, right? The same thing happens when we divide. You're used to this. You're used to saying 23 into 46. Oh, good, that's a 0. Well, that doesn't go. bring that down. Okay, okay, I know how this goes. It's 204. So then you get to this thing and you say, oh, I know how this is supposed to go. And you learn this trick when you're in school. And they say, you know what you do? You just move the decimal point till it's at the end over here. And then you keep track of how many places you move the decimal point. Then you move the decimal point that many places over here. You got to keep track. However many places you moved it here, you got to move it here. And then you do that division problem and it's the same answer. And because it's literally this problem, it's going to be the same answer. Why? Why does that work? Why is that a thing? Well, consider the following. That's what we're doing, right? We're dividing. That's a fraction. So we can multiply by the same number in the numerator and the denominator and then hold the value because this fraction, this is just 1. Well, why did I pick 10? Because I wanted to kick this decimal point over way to the end. I wanted to move this to here. That's 1 place. That's 1 power of 10. And then we do the same thing up here. And so just what we remember about fractions tells us that whatever the answer to this question is the answer to what this question is. So the red question and the green question have the same answer. That's why it works. It doesn't just work because, oh, now we're dividing. So here's this special trick that we do when we're dividing that we swear works, we promise. There's math involved here, and that math involves equivalent fractions, making sure that this fraction is the same as that fraction by always multiplying numerator and denominator by the same quantity, because this fraction is 1. Okay, so what should you know at the end of today's lesson? You should be able to verbalize why we add the way we do, why we subtract the way we do, why we multiply the way we do, and why we divide the way we do. You should be able to verbalize. So then make up your own questions. Make up 2 decimals to subtract and explain to your friends, here's how we subtract. Record your own YouTube videos on how we subtract. Or pick 2 decimals to multiply and multiply those decimals. Make the arithmetic easy. Use nice small digits. Divide, same thing. Make up a division problem with decimals in it and make sure that you know how to run the process through and why that process holds, because our course is predicated on you not only knowing how to do elementary school arithmetic, but on how to teach young people why it works. So that's my explanations on the questions in the worksheet. All the best until we gather again.